Problem number 32, we're asked to write the symbol for the ions. And these are going to lose valence electrons, so these are all going to become cations. So you get a positive ion, we call those cations. All right, it is very important that you get this down second nature before we move into bonding. So we're trying to show why do these atoms lose electrons in the first place. Is to achieve the octet rule. So they want to have the same electron configuration of these noble gases. All right, let's go right into aluminum. Got to quickly recognize where these things are on the periodic table. And once you find it, you go to the group number. The last digit tells you the number of valence electrons. And you know all these main group elements in group 13 have electron configurations that end in S2, P1. That's why they have 3. That's why that last digit is, well, that's how you can know. So for aluminum's got 3 dots, 3 valence electrons. It's going to lose all 3 of them. And it's going to have a symbol of Al3 positive. You can put brackets around if you want to emphasize that charge. Now let's move on to lithium. All of these elements in group 1 are going to have their final electron configuration as S1. That 1 electron tells you it has 1 valence electron corresponding to the group number 1. Li, lithium, 1 valence electron, it loses that. Well, think about this a different way here. Lithium has 3 protons. It usually has 3 electrons. Well, it just lost 1 of these, and now it's down to 2 electrons. So now what's the balance here? Got 3 positives, 2 negatives. The overall charge is 1 positive. So there's your answer for lithium. Let's go on to barium. All of these alkaline earth metals in group 2, you already know has 2 valence electrons, and that's because they all have their final electron configuration ending in S2. That's why it's called the S block. So barium, as well as all the other alkaline earth metals, have 2 valence electrons they are going to lose. And why do they do that? To look like a noble gas, right? Barium's going to lose 1, 2, and then it's reached the electron configuration of its noble gas as xenon. All right, so it's going to look like, put brackets around it if you want. There you go. Potassium. Potassium group 1, 1 valence electron. It's going to lose that, and it's going to have a 1 positive charge. Moving on. Not too hard, right? Calcium, group 2, right there. Calcium's like a knight with 2 swords. I'm not going to do that. Lose those 2 swords, become like a noble gas. Noble, get it? Knight to noble? I don't know. Alright, so it's going to be 2 positive. Let's see, 1 more to go. Running out of... Here we go. Strontium right above it. I'm sorry, right below it. That also in barium. It's going to look the same. Alright, again, if you group 2, alkaline earth metals, 2 valence electrons, they lose to achieve the octet rule. Put all the answers right here next to it. Al3 positive, Li positive, Ba 2 positive, potassium 1 positive, calcium 2 positive, and strontium 2 positive.